Welcome to Tutor Sam Academy, where complex is made simple. Today we're studying Simple Machine, but before that, subscribe to our YouTube channel.
Welcome. Today's physics will be taking Simple Machine, and the objective of today's class is we'll be starting with the definition of machine. We'll be looking at some terminologies that relate to its machine. We're talking about mechanical advantage, velocity ratio, and efficiency of a machine. Then finally, we'll be talking about the types of machine. So follow me carefully. All right, let's look at the definition of machine. Machine, we all know what machine is all about. We have been using the word machine. But by definition, machine can be defined as a device or tools which allow a force applied at one point. It allows a force applied at one point to overcome a resisting force at the other point. So there are two forces there. There's a force applied, and that force that is applied, is referred to as the effort. So machine is a device or tools that allow the force applied at one point, that is the effort, to overcome a resisting force at another point. So the resisting force is referred to as the load. So there is force applied and there is a resisting force. So indirectly we can say machine is a device or tools which allow the effort applied at one point to overcome the load at another point. So the basic aim of a machine is to use effort to carry out a load. So if you are using your wheelbarrow, you will know that your wheelbarrow is a machine. It requires your effort to carry out the load. So the force applied is the effort, and the resisting force which you are applying your force to is the load. So that is all about the definition of machine. All right, let's look at some basic terms that are used in simple machine. Now, one is mechanical advantage. What is mechanical advantage? Mechanical advantage is also referred to as force ratio. And by definition, mechanical advantage, it is referred as the ratio of load to effort. Referred to as the ratio of load to effort. So mechanical advantage, let's abbreviate mechanical advantage to this, is referred to as load, the ratio of load over effort. So when you divide your load by effort, you have your mechanical advantage. And don't forget, from my definition of machine, I said load is a force. So the unit of load is Newton, because the unit of force is Newton, and the unit of effort is Newton, because I said this is an applied force, and this is a resisting force. So Newton divided by Newton will cancel each other. So we can say that mechanical advantage has no unit. So that is all about mechanical advantage. It's the ratio of load to effort. Load, if we are to define load is the amount of substance overcome by a machine. Load is the amount of substance overcome by a machine, while effort is the force applied to that machine. So number two, let's talk about velocity ratio. Velocity ratio, this is the ratio of distance moved by the force to the distance moved by the load. Distance moved by the force, the ratio of distance moved by the force to the distance moved by the load. Distance moved by load. So let's just be giving brief definition on all this terminology. This is load divided by effort. But when you look at your velocity ratio, you see that effort or force is coming up first. I can call this force or effort, but let's use effort. because I use effort here. So effort is coming up first, while load is coming under. So that is the short way to know your mechanical advantage to your velocity ratio. Mechanical advantage is just your load divided by your effort, but velocity ratio is distance moved by the effort to what? To distance moved by the load. So that is all on velocity ratio. All right, let's talk on efficiency of a machine. Efficiency of a machine is the ratio of, we have talked about mechanical advantage and we have talked about velocity ratio. Efficiency of a machine is the ratio of mechanical advantage to velocity ratio as expressed in percentage. It is expressed in percentage. So the ratio of mechanical advantage to velocity ratio as expressed in percentage is referred to as the efficiency of a machine. I'm going to give you different definition of efficiency, but let's take this first one first. The ratio of mechanical advantage to velocity ratio as expressed in percentage is our efficiency. Don't forget, we say mechanical advantage is load over effort. So this is only mechanical advantage divided by velocity ratio. So I can say divided by velocity ratio multiplied by 100. So this is load over effort. This load over effort is coming from our mechanical advantage. This division here is coming from this division I have here, and this is my velocity ratio. So if I'm to change this division to multiplication, mathematically, when you are changing from division to multiplication, you take the reciprocal of velocity ratio. Reciprocal means that if it is velocity ratio over 1, it will become 1 over velocity ratio multiplied by 100. So this is our formula for efficiency of a machine. Efficiency of a machine can also, aside from that definition, can also be defined as the ratio of work done by the machine to the work put into the machine. Can also be defined as ratio of work done by the machine to work put into the machine. The ratio of work done by the machine to what work put into the machine as expressed in percentage. So this is also definition of efficiency of a machine. And work done by the machine, don't forget that work done is force times distance. So our force here will be load times distance moved by the load, divided by work put into the machine. Here the work put is your effort. What you put is your effort. Effort times distance moved by the load as expressed in percentage. Let me explain this again. Aside from the definition of mechanical advantage to velocity ratio, efficiency of a machine can also be referred to as work done by the machine. Work done by the machine. When they say the efficient, what the capacity of that machine is just that the work done by that machine, what the machine has done. When you divide it by what the effort you put into the machine, work put into the machine, that is the efficiency of the machine. So work done by the machine is load times distance moved by the load. The reason why I say it is load times distance moved by the load is because when you are experiencing work done is force times distance. But when you are considering in terms of machine now, the work done will no longer just be force, it will be the load. Don't forget, load is a force. I call this it's called the resisting force. Resisting force multiplied by distance moved by the load. Then work put into the machine is your effort. So force in these times will be our effort. Instead of force times distance as work, it will be effort times distance moved by the load, because effort is an applied force. Thank you very much for watching. Do well to like, subscribe, and share.
Thanks for watching. For personal online or offline classes, message us via the link provided. Subscribe.